Southeast Asia or in the islands of the Pacific to coastal communities in the Mediterranean to communities right here in the good old US of A. What I want you to do next is to pause this video and this screencast video and watch this video from Al Jazeera on how sea level rise is impacting communities in southern Louisiana. You can find a link to this by using the PowerPoint presentation associated with this file. Get to this slide and click on the image, or you can click on the link that's in Moodle. All right, welcome back after watching that short video. I chose that one because of several things. Number one, it's regionally relevant because it's here in the South, focused on communities here in the Southeast. But secondly, it also features how sea level rise is impacting everything from local cultures in a particularly diverse region of the Southeast. Lots of various cultures that live in South Louisiana. Not only cultures, but the economy. It explained the importance of the South Louisiana to the oil and gas industry. A lot of the oil and gas that we use throughout the U.S. comes through this region. So those facilities that process that, those petroleum products are at risk. And then lastly, of course, we saw the impact it's having on ecosystems. We got to see a little bit about like what happens as these ecosystems are exposed to more and more salt water as the sea level rises. We'll learn more about that coming up. What I want to do next is introduce you to a tool that can help you visualize how sea level will impact different areas of the world. Some of you are from coastal communities. Some of you visit coastal communities from time to time, or you know people that live there. And I want to show you this tool that helps you see how much land will be lost as a result of sea level rise. And I'm going to focus on the community in which I grew up, which is featured in this picture here. This is Gulf Breeze. It's in the middle of Pensacola Bay. And I'm going to pause here and get it set up to show you how to use the sea level rise viewer. Okay, so here we are at a web page from NOAA. Again, that's our National Oceanic and Atmospheric Administration. And this is their way to help everything from citizens to policymakers to politicians and so forth visualize how sea level rise will impact different communities. So this is you'll find a link to this web page on Moodle, or you can link to it through the PowerPoint that's associated with this video lecture. When you get to the web page, you'll see that there's 3 buttons over here. You'll want to click the launch button, and then there's some information. You click the get started, and you start off with a map. Over here on the far left, you'll see that you've got a slider bar, a vertical slider bar that lets you go up to different levels of sea level rise. There's also a lot more information on here. There's local scenarios that are developed for areas to show and feature a little bit more narrative about what's going on. There's data on how confident we are, or NOAA is, with the mapping that they're presenting here. There's information about marsh migration if you want to zoom in and look at that. There's looking at the vulnerability of different populations. So there's way more here than we're going to explore in this little bit here. But let me take a look at the area where I grew up. So up at the top, there's a little window. You can put in the name of a city. I'm going to put in a zip code. There we go. So now this is zooming in on the region where I grew up. This is the Alabama-Florida line here that you see center left. There's Gulf Shores, and then this bay over here to the right is Mobile Bay. This is Perdido Bay right here, and then this is Pensacola Bay area where I grew up. All right, so here we are in Gulf Breeze. Right here, it's sort of sandwiched between the mainland up here in Pensacola and this long barrier island called Santa Rosa Island. We'll be talking about barrier islands in a few minutes. Zooming in on Gulf Breeze here. So this is, like I said, the community where I grew up. And let's take a look at what would happen with about, we'll say 4 feet of sea level rise which is well within what we can expect sometime this century or just beyond. So I've moved the dial on the far left up to 4 foot of sea level rise, and you see that a significant amount of the Gulf Breeze city falls underwater. Again, let me do that so you can see the difference here. So this is at this is where we are now. This is at 1 foot, 2 feet, 3 feet, and 4 feet. And what I want to just comment on here is that these are low-lying areas of this peninsula that sticks out into the bay. And despite the fact that a lot of this is very wet and low habitats, even several decades ago, developers were allowed to buy the land and to build homes on it and then sell that to the public. And now a lot of people are now living in these areas that are highly vulnerable to sea level rise. So this is, of course, going to significantly alter the shape of the community in which I grew up. But this is just like one little slice of what we will see in many communities throughout the world. Let's take a look at another one. Let's go over to New Orleans. Let me pause and get that set up. Okay, here's the New Orleans region. You see the Mississippi River here coming in from the left and in the center of the screen, running through the city here and then out, down, and into the Gulf of Mexico. I will point out that a lot of this zone out here, just off of the end of the New Orleans region, this is area that used to be covered with marshland, but we've already lost that, as we saw in the previous video. So right now I've got the sea level rise set at 0. Let's take a look at what happens up at 4 feet of sea level rise. So here's 1 foot, 2 feet, 3 feet, 4 feet. Okay, and you'll see that everything that's in light blue coloration here is land that was that is currently exposed. A lot of that is low-lying marshland for sure. But everything that's light blue is now underwater. Okay, so the amount of, let's go through that one more time. Here it is at the current level, and then zooming up here to 4 foot of sea level rise. Now the reasons that you see these strong lines here that aren't moving as you add more feet of sea level rise is because these areas here that I'm tracing with the cursor, they are protected by walls of earth called levees. And so you need a very highly significant amount of sea level rise to overtop these levees. These levees, of course, are essential to protecting New Orleans. One of the things, though, that is not represented by this website is the fact that as sea level rises, more waters from the oceans will saturate and infiltrate through the soils underneath those levees and make the lands that are protected by the levees, so that would be the interior of the New Orleans city here. It makes those lands much more vulnerable to flooding, because with the soils saturated with water, every time it rains, the water has nowhere to go and it just builds up. New Orleans already has problems with this, as I think you're aware. New Orleans has to run pumps continuously to pump water out of the city, and during hurricanes it's very vulnerable, as we saw in Hurricane Katrina in 2005, when over 2,000 people died as a result of flooding in the lower Ninth Ward and other areas in New Orleans. So here we are, looking at the future for New Orleans, and things are looking not so great if we continue onwards and have 4 foot of sea level rise. Now, what I want to talk about next is what are some of the early signs of sea level rise. Back when I was learning about this, roughly I was your age, I was thinking about sea level rise as sort of basically like the coastline just coming in sort of gradually and swallowing up the landscape. But as it turns out, it's not so simple, which makes sense because ecosystems in our planet are very complex, and things are not always just sort of linear and obvious like that. What we actually have to consider in the case of sea level rise is that the oceans are subject to gravitational pull by the moon and the sun, and for those reasons we get the water levels along our coasts go up and down on a daily basis. Most areas of the planet, most coastlines of the planet get 2 tides a day. When water levels are high, we get high tides, and then there are 2 times during the day when we get low tides. Those tides vary in how strong they are. When the moon is full, or it's in the phase that we call the new moon, when it's completely blackened from our perspective, we tend to have the very highest of tides that we'll see during a month. And during certain times of the year, when the Earth is closer, I believe it's when we're closer to the sun, those tides are even stronger than they are normally. So we have variation in tides within the day and throughout the course of the year. And there's a phenomenon when tides get so high that they spill over into the built community. So that's our streets, our houses, our shopping areas, our schools and churches and so forth. When they spill into the built community, we call that high tide flooding. And as it turns out, we're already seeing lots of high tide flooding throughout the southeastern United States. So this is a picture from Charleston, South Carolina sometime recently. You'll notice that there's like floodwaters on the streets and the sun is out. So this is what's often called by folks a sunny day flood. A lot of times, as we'll talk about soon, this is coupled with having high tide flooding is coupled with rainfall and other events that can cause that that tide to be unusually high. You can see images like this up and down the eastern coast especially, and in parts of the Gulf Coast. In the year 2018 was a year where we had we tied our record for the number of high tide flooding days. That's kept track. That's a value that's kept track by NOAA. This is an image from Washington State. And the number of high tide flooding events has been increasing significantly over time. High tide flooding is a combination of several things. First of all, it's the high tide. That would be your top blank here, is the high tide occurring. And with one of these other features, such as strong winds blowing water ashore, or a shift in currents that can bring more water against the continental mainland or an island. Or it can be a high level of rainfall that saturates soils, and then therefore the soils are unable to drain the water out and away. One other problem we have in the built environment is that with a lot of rainfall and the soils being saturated, the rainwater is not able to travel through our stormwater systems. That's this last blank right here. So we're going to take a look at some of the projections now and these high tide floods and what it looks like for communities in the southeast. This is an image, an infographic from NOAA. And what we're looking here at on the x-axis is a timeline from the year 1960 to projected out to the year 2100. What we have on the y-axis is high tide flooding in terms of number of days per year. And just as a reminder, these are days where the water level has risen up and beyond a level that's considered a nuisance flood or a nuisance tide. And when that happens, that's classified as a high tide flood. What you see with the little dark black bars that are along the x-axis up into around the year 2016 or so is the actual number of measured days when we've had high tide flooding. What you're seeing with the colored bands represent projections on how much high tide flooding this area will see into the future based on different climate scenarios. So the location is a place on the Georgia coast called Fort Pulaski, and we see different projections here. The gray line here, so right where I'm moving that cursor around the boundary between the dark blue and the gray, that represents the projection moving forward based on what we've seen from 1960 to the year 2016. If you just extend that line outward, that's the amount of high tide flooding you can expect to see into the future. And so you could see that by the year 2100, we would expect to see high tide flooding on 100 days out of the year. That's nearly 1 out of every 3 days in the year, a high tide flooding event. The dark blue line here, so that would be at the boundary between the light blue and the dark blue, that is representative of the number of days of high tide flooding we'd see at an intermediate level of climate warming. The top of the light blue wedge here represents the intermediate levels of climate warming and carbon loading into the atmosphere. And the red line, of course, is our extreme scenario, which is best represented by RCP 8.5, the business as usual model. And what you see here is that these models, especially the extreme and the intermediate, they peak out at around 365 days of the year. But we see that a little at about mid-century with RCP 8.5. So we see that the line here, the red line, the very top of it, hits the very top of the graph at 365 days. And if we drop down to the x-axis, we see that that's going to be at about the year 2050. Whereas with the intermediate level of warming, we hit 365 days of the year around the year 2085 or 2090. Now, remember, these nuisance tides do a lot of disruption along the coast, but not like what we see with hurricanes. We'll talk about that in a few minutes. You get a lot of flooding on your streets. You get water backing up through our stormwater systems and flooding yards and parking lots and these sorts of things. Keep in mind that a lot of this is going to be salt water, which because of the salt in the water, it has a corrosive effect on a lot of materials, including some metals. So this is not a healthy way for a community to survive. It's going to gradually eat away at the infrastructure and cause the cost of living in these communities to rise. To drive this point home even further, this is a quote from a NOAA report that came out in October 2019. They say that disruptive and expensive nuisance flooding is estimated to be 300% to 900% more frequent in U.S. coastal communities than it was just 50 years ago. So that's our current condition. We are 300 to 900% more frequent than 50 years ago. Now, nuisance flooding is, of course, an issue, but so is the kind of flooding that we get with our big storm events. And that would be seen most dramatically with hurricanes. And that's where I'm going to end this part 2 of Introduction to Sea Level Rise, and we're going to pick up with hurricanes in our part 3.